Our first speaker, I think we're still on time, Dr. Halley Froelich. And Halley is a postdoc, and she did some really great work on modeling forage fisheries and the talk I mentioned before. She's just finishing up her postdoc at the National Center for Ecological Analysis and Synthesis at UC Santa Barbara, right? And will, I thought it said where you were going to be going on to next year, but anyways. Oh, CART, yeah, there we go. Conservation Aquaculture Research Team. We'll be doing some work there. And so PhD from UW, University of Washington, and bachelor's from UC Davis. So, Halley, please come on up. Big green for advanced, little one for back, and
Thank you so much.
okay.
Hi, everyone. And just for clarification, the pronunciation is Halley. I know, blame my parents. Also, my last name is atrocious. It's Froelich. Yeah, so just, and no harm at the mispronunciation. I've had it all my life. But I'm really honored to be here in a room full of people thinking about the future of aquaculture, which I do on the daily. And so hopefully I can bring some of the global perspective to that from a scientific realm. So I think most of us here recognize that in the public arena, that fisheries and aquaculture end up being pitted against each other, right? The narrative of fishing versus aquaculture. But the people sitting in this room are very well aware that these two systems are inherently interconnected, and these connections are only going to get stronger as aquaculture increases and anticipated to surpass all capture fisheries in the next couple years, according to FAO. And it's this part that I think this is why we're all sitting in this room, right? That all capture fisheries. And what I'm going to focus on a little bit more, talking about forage fish. It's one of the most efficient ways of extracting biomass out of the ocean. This is an example of one haul that you can bring in, billion-dollar industry, really efficient in the way that we capture these organisms, and ultimately really essential for aquaculture and other forms of cultivation. But as was mentioned in the previous talk, it's not just all about what we can get out of the ecosystem, right? There's this balance and this important linkage that forage fish provide. So sardines, herrings, anchovy, menhaden, they can play a really critical link of transferring energy from the lower trophic levels up to things that we care about, whether that's intrinsic value like whales or other things like salmon and rockfish that we commercially harvest. So all of those things combined ultimately led to this question that myself and my colleagues, both on the fisheries and aquaculture side, came together and said, well, what is the ecological limit for forage fish? And how does the future of aquaculture fit into that space, right? We're well past the discussion of whether aquaculture should or shouldn't be in our food system. It is. It's a critical part now. And so we really need to get our heads out of the sand as scientists and start thinking about these types of larger scale questions. But to do that and to answer that type of question, that's a global level question that we're stepping into, right? So that means that we're going to have to track down a lot of data. And with that data, get the context of answering that question. What are the things, how can we answer this question given the sources that we have? So we spend a lot of time and effort honing this question to collect an exorbitant amount of information of some of the papers and studies of people sitting in this room, aggregating all that information together to answer kind of three important aspects to this question. First was to collect information on the fishery side. What are the trends that we're looking at now? Is there a role to play in terms of improvement in fisheries management to this future with forage fish? Obviously, the aquaculture side of things and other cultivation demands as well. And ultimately, thinking about future challenges. What are the uncertainties that we're facing into the future? And this part of it really sets the framework for bounding the thing that we want to do, ultimately model out what possible futures there might be. So let's start with the fisheries. So forage fish stocks are highly variable, as mentioned. We're all very well aware of this. Here's an example of just 6 different types of forage fish dynamics. So a lot of variability, most of that's driven by environmental condition. But new research is coming out, some of which I was a part of, that looked at, well, what's the role in fisheries in this? And an important thing that we found, although most of it is driven by environmental conditions for these ups and downs, when forage fish start declining, what we see the fisheries start doing, fish harder. So that's not a great way to manage a fishery. You don't want to fish harder when you start declining, but that's what we see, which can result in those troughs there on each individual stock getting even lower, which means that there's a higher chance for collapse and a longer remaining time in that collapse, which is not good for the environment, but it's also not good for the industries and the downstream user groups of this. So it then begs the question, could we do better? And can we get more out of the system then if they were better managed? And from a global aquaculture perspective, while each individual stock, really important at an ecosystem level, for aquaculture, especially in the compound feed perspective, it's this portfolio effect of these stocks being available, excluding Peruvian anchoveta, which we know has a really important impact on those prices. But overall, it's the aggregate that really matters here. Okay, so fishery side, check. We wanted to collect information there, get context, but we also need to look across another food system, right? Aquaculture and fisheries are not operating in isolate from themselves either. We have this other food system also depending on forage fish, or at least consuming it as well in the livestock industry. So we have to look across all of our food to really look at this question. And on top of that, we want to collect information on taxonomic differences, on country level information, and the advances that have been made in husbandry and technology within this space. So we tried to garner as much information about these individual species, taxonomic groups at the country level, some of which are listed up here, and try to embed that into a model that informs us about the future. So then, once we have all that information, we can step back and say, okay, what are the questions that then we can ask about our future? We can ask kind of the simple ones. All right, we're gonna anticipate increases in production, so let's account for that. We ended up focusing on future being 2050. Most of the models these days, those estimates are pretty good, so we ended up going with some models that approximate aquaculture about doubling. That's not the case for poultry or pig production, but we wanted to account for that. We were also, as I mentioned, really interested in trying to embed some of that variability or anticipated change of percent organisms that are on feed, as well as what's being included, what's the percent inclusion of forage fish over time. And again, thinking about the country level as well, it's not just about the individual species, but what certain countries, especially the big players in this field, like China. So the top ones are kind of things that people have already thought about in some way, shape, or form, either qualitatively or quantitatively. We wanted to ask questions that maybe kind of got overlooked, like human diets. So what are we going to be eating by 2050? What does our global landscape look like? What if people started eating more farm fish, like the poultry industry? That didn't exist 30 years ago in terms of its relative importance in our food system, and now it's the dominant meat product that we raise on land. So what if humans had a come to a health moment and said, I'm gonna listen to my doctor and eat more seafood? What would that future look like? We also wanted to consider the fisheries landscape as well. What if ecosystem-based fisheries management was set into place for forage fish? What would that mean? And of course, the elephant in the room, climate change, right? All right, so that set up the space for data across countries, species, and different food sectors, in the context of which we could actually ask those questions. I was gonna show a whole bunch of math to you, and then I thought, maybe I won't. So what I'm going to do is kind of go through the structure of the models that we built to answer those questions and then show some of those results. So we split it out in two ways. We developed a what we termed an ecological supply model. And that was just to get a better sense of what are we taking out of the system now, where will that be in the future, and can we get a little bit more? So this ended up capturing 401 different stocks, 238 different species, about 99% of everything that we consider forage fish. And while we looked at kind of the business as usual forage fish access, we also ended up running a model approach, data limited model approach, to figure out what the long-term sustainable yield is for forage fish, which is extremely challenging to do, but we have a lot of computational power now and new methods to apply. We then applied a cultivation demand model. So we can compare forage fish supply on the fishery side to then the cultivation demand of both agriculture and aquaculture, and look at those future scenarios and where those end up running into each other. So can we forestall reaching forage fish limits by 2050? What does that look like? So the graph that you're looking at here, that's biomass over time since 1950 of forage fish. The gray line at the top, that's the historical supply that we have from forage fish. That dotted red line, that's the historical feed use over time, tightly coupled. That dotted black line right there, that is where we are now. And so everything past that is the model scenarios of the simulations that we ended up running. And the simulations, I should mention, this is not an absolute. We're not saying these are the things that are going to happen. What this allows us to do is to explore the uncertainties and what the effects are of certain mitigating measures. That gray straight line that you're looking at there, that's the current average supply that we ended up using for our baseline of if we don't change fisheries, on average, this is what you have available into the future. Of course, there's going to be a lot of variability because they're naturally variable, but at least this gives us a gut check of a baseline of what we might anticipate. So what if we apply management reform to all our forage fish fisheries? Are we going to get an extraordinary amount back out? Not really. So the maximum sustainable yield for forage fish ends up resulting in about 1.7 million extra tons on average. Again, variability around that, but you do that large-scale reform for all those fisheries, very challenging to do to begin with, and you get these kind of two components of ecological supply. So let's compare that to cultivation demand then. So here you're looking at the business as usual scenario. And when I say business as usual for this particular study, it means if we stop changing what we're doing now and we just keep doing it into the future. Obviously, that's not the case. Aquaculture has gone through a lot of changes and will continue to do so. But what we wanted to do was, again, set a comparative baseline to say, if we didn't change anything, what would that look like? So if we do improvements, how much of that do we save or spare or bring demand down? We need some baseline of comparison. So when we do that, we find, not surprisingly, we start bumping up against the ecological limits of these forage fish if we continue doing just what we're doing now today. So what if we change something? And I'm just going to walk you through one of those individual scenarios. We ended up looking at, well, what happens when we reduce just a small percentage of forage fish input, assuming that alternative feeds are going to be replacing them? What happens in terms of savings there for carps and other non-obligate predators? So we wanted to look at that flexibility, and what we find is that you get one of the largest savings into the future when you do that, of just a 4% reduction. But you have a massive reduction in demand. And we did that for a suite of things, right? But the important thing to take home is not how much you save from each individual one, because ultimately no one thing ends up being the solution. And that's the really important part. When you aggregate all of these mitigating measures together, that's when you see the success story, right? So there's no one silver bullet to answer this, but alternative feeds will play a very important role in different aspects to bring that demand down to a level of which is comparable to what we're at right now. But of course, we're scientists, so we wanted to poke and prod our model and see what happens when you perturb it. For instance, if diets shift to pescatarian, across the world we eat more farmed seafood, the mitigating measures and the percent level changes that we investigated ultimately break down, and it's not fast enough to keep it underneath those two lines. Other future uncertainties, as I mentioned, ecosystem-based fisheries management. What if that came to pass? What would that mean for aquaculture industry adapting? That would result in about a 20% reduction in catch limits, which would equate to about a decade less of time to have access to that resource, or alternative feeds being adapted into the industry. Climate change. Now, this is a tricky one, and we're still working on it. It's really hard to predict how forage fish are going to respond to climate change, but so far with the information that we have, odds are it's going to be stock-by-stock basis. It's likely going to be more variable, but on the whole and collective for aquaculture, at least according to FAO's most recent report on climate change and fisheries, you might be okay. That will have levels comparable to what we have now. And maybe some of you are sitting in this room thinking, well, none of this is going to come to pass. You just said these were simulations, but I want to preface that these two things that I just described happened in real time just a couple days after we published this paper. Atlantic herring, one of the largest stocks in 2013, second to only Peruvian anchoveta, ended up collapsing, was overfished. It is now depressed, what we think is driven by warmer waters. And as a result, they officially set in the ecosystem-based management criteria for this and reduced that catch limit by 20%. So we're seeing this play out already in real time. And so it's something important to consider. We also looked at efficiencies, not an explicit scenario, but we found that that can be one of the largest savings or reductions in demand. And that could be through selection, through feed, or through environmental conditions. But the important part here of all of us sitting in this room, feed is again connected to this type of saving. So fishing reform is not the sole solution, though helpful. It's going to be a portfolio of aquaculture measures that are key. Alternative feeds are a massive player in that. More rapid adoption not only adds sustainability, it adds stability in general. I don't have to tell you guys that. And efficiency, right? We know efficiencies are great environmentally and economically. And I just want to end with the global meta-analysis coming down the pipeline. So my colleagues and I have been poring over about 300 to 400 papers looking at what the effects of alternative feeds are in the scientific literature of that graph that was shown earlier. And the important thing that initially we're finding is that those individual numbers are experiments. Note that meal has a lot of very high number and fish oil does not. So it's really good that you're all sitting in this room today. And so with that, I'll thank you.